I'm Landon Bunderson. I'm the Chief Science Officer of aqua. We're lucky to have the University of Utah close by. We've been able to use their facilities, their electron microscopes and their other equipment to characterize and to improve our technologies. As we came up on campus and began using their equipment, we discovered a whole institute of nanoscientists, students, postdocs, and professors. This has been invaluable for us to develop our technologies in collaboration with the University of Utah.
Problems that we deal with in delivery of bioactive agents, drugs, are very similar to the problems that you want to deliver agrochemicals to the soil. So you have to cross barriers. First, you have to load a lot of these agrochemicals into nanomaterials. And the second thing is that you have to cross a lot of barriers to get to the place that you want. So as a consequence, the problems of delivery of bioactive agents, whether it's for human health or for agriculture, are really similar, and our lab is equipped to cross those barriers with nanoparticles.
In our lab, we do a lot of practical experiments on plants, characterizing how the nanoparticles affect the plants and the growth stages of the plants. We do a lot of experiments in the field on farms, but it's here at the University of Utah that we're able to develop new nanotechnologies and improve our own nanotechnologies. The wealth of information, the wealth of facilities, the brain power that is up here has been tremendously helpful in helping us improve our technologies and develop new ones.
I think aqua is at the forefront of using nanotechnology for the delivery of agrochemicals. I think it's a real wonderful chemistry, that it's a local group that we work together. And also it makes Utah stand out in terms of using nanotechnology for delivery of agrochemicals. Nanoparticulate matters, it takes a lot of skills to really make nanoparticles that are really well defined and they can be used in different agricultural products. So there are two ways to make nanoparticles. One way, what we call bottom up, and the other one is top down. The approach that we're choosing for the products that aqua is interested is mostly bottom up. You put a whole bunch of chemicals into a solution. There are certain things that you need to do to them, and then as a consequence you get these really wonderful, good-looking nanoparticles. I think you can always oversimplify science, but at the end of the day, good science is really complicated. But you also have to make sure that you do a science that is going to be affordable for masses of people, and so that you try to break down those concepts into simpler forms. And so I wouldn't say that it's so easy to make these constructs, these nanoparticles, but I think our lab has enough experience to make sure that they are done in a repeatable fashion and a reproducible fashion. I think we're on the right track, because with sustained delivery, we're going to save costs, as well as we're going to produce a better product.
Over the last 10 years, we've identified that you have to check the characteristics of those nanoparticles very, very carefully, and especially those that are going to enter the human body, as well as the animals, as well as to their use in their agriculture, to make sure that they are safe and efficacious. Because Gandhari, in his research, has only dealt with how silicon nanoparticles work in the medical field, and never considered the possibility of working in the agricultural field. And so it brought two fields together and has been very, very successful.
Nanoparticles have been used since the 17th century in the manufacture of stained glass. It's actually nanoparticles that refract light and make the reds and the yellows in the stained glass. At the time, they didn't know that they were using nanoparticles, but that's actually what makes the color in stained glass. The word nano actually comes from the unit of measure nanometer. In short, nanometer is very, very small. To give you an idea of the size of a nanometer, think of a poppy seed. A poppy seed is 1,000,000 nanometers in diameter. A plant cell is 100,000 nanometer. Okay. A plant cell is 100,000 nanometers in diameter. 1,000 times smaller, you get into the nanoscale, 1 to 100 nanometers. That's where the magic happens. You can't see a nanoparticle with a conventional microscope. You actually have to use electrons and what's called an electron microscope to get a visualization of a nanoparticle. Even though nanoparticles are small, they have a big influence in our lives. They can be in shampoos, they can be in the food you eat, they can be in sunscreen. Take sunscreen for an example. The nanoparticles in sunscreen interact with light. Much like the nanoparticles in stained glass, the very small nanoparticles in sunscreen interact with light. They actually absorb the energy coming onto your skin. Because of that, it prevents you from getting a sunburn. Researchers have been using nanoparticles in nanomedicine for years. They attach a drug to a nanoparticle and use it to deliver the drug into a space that might be hard to get to. They can carry drugs more efficiently through bloodstream, they can penetrate tissues, and get a better effect with less drug. The same technologies that are used in drug delivery can be applied to agriculture to deliver things to plants. AquaYield is a leader in nanotechnology in agriculture. Here at AquaYield, we develop nanotechnologies that improve your crops and reduce the amount of product you need to use. Our innovations are improving agriculture one nanostep at a time.